Well, welcome to the continuation of Networking Basics. And the segment here that we're going to be spending some time on is IP version 4 and IP addressing. And this subject is a little bit on the mathematical side, but don't be frightened at all as I begin to talk about it and begin to try and explain to you what it's about. I want to give you a very good grasp of what IP version 4 is about and how to think about it when you start looking at networking and how we use this address. It is an addressing scheme that was created by the IETF to help handle the needs of finding the machines when you have something as vast and large as the internet, and finding the right place to go and routing packets and so forth is going to require a pretty sophisticated way to assign addresses so that email can be delivered and web pages can go to your machine or my machine, and we can find different companies, web servers, or if we're a traveling salesperson, to even be able to find our intranet that we can log into so we can get information that we need to do business with. So the way to think about an IP address, especially in version 4, is it is a 32-bit number, which forms a unique address for each host connected to the internet. No two hosts can have the same IP address. The assignment and maintenance of IP addressing is maintained by Internet, and the IP address is written in what we called earlier in the lecture dotted decimal, which is base 10 notation. And it is represented by 4 8-bit binary numbers with the range from 0 to 255. And 4 times 8 equals 32 bits. And it's represented, of course, in binary, which is 8 zeros, 0, 0, 0, 0, 0, 0, 0, 0, to 8 ones, which is 1, 1, 1, 1, 1, 1, 1. And the decimal will go from 0 to 255. And what I just gave you in binary is 0 to 255. IP addresses are actually organized according to classes. And the ones that are used on the internet are Class A addresses, Class B addresses, and Class C addresses. Class D, is an address range that is reserved for multicasting, and Class E is reserved for future address use. And also we have something called a loopback address, which we will talk about shortly, which starts with 127. The range of addresses, you look at the first unit, the first decimal number, and you can tell what class address you're in. So we have a net ID portion of the address and the host ID portion of the address. If you have a Class A address, it uses just that first dotted decimal number. So if you had an IP address that was, say, 172.87.16.0, the 172 is the first portion of the address. Now the thing about it is there is a range in Class A. There's a numerical range. And you have to remember that it goes from 1 through 127. Now the range, that's the range of the network ID from 0 to 127. The range of Class A addresses runs from 0.0 0.0.0 to 127.255.255.255. So you remember from 0, actually I should say from 0 to 127 as representing Class A addresses. Now, however, there's a loopback address that uses the 127 for a special purpose, and we'll get to that in a minute. The Class B address is used for medium-sized networks having more than 255 hosts, but its range for the decimal numbers starts with 128 and goes all the way to 191. And what we need to understand is that these ranges of address give us a certain amount of net IDs as opposed to a certain amount of host IDs, so that we can have addresses for different machines on our networks. Class A addresses, the network ID is, they're able to have network IDs that range over 16 million. But there is not as many host IDs available. So you lose something in terms of your addressing. The Class A address, while it can have more net IDs, like over 16 million, it can only have so many hosts that are available for use in a Class A address. Class B addresses will use more in medium-sized networks and not large organizations like Class A address uses for. Class B will have networks having more than 255 hosts, and it can have up to like 16,384 different networks, but have no more than 65,536 hosts. Now, by the way, these hosts are also called nodes. So it's another way to refer to how many net IDs you have, how many host IDs you can have. These are per host, per node. So there's a kind of a medium range for the Class B address. Then you got the Class C address. It's used for networks with a smaller number of hosts. Okay. But you have a lot of, you have less net IDs, but you can have more significant hosts. Again, you want to try and find out what all this means by maybe doing some Google research, and why I've, kind of tried to explain to you why you have addressing the way it is, and why you would choose maybe a Class A address as opposed to a Class B address or a Class C address. The network address is the host portion, and you will find out that the net ID is governed by what's called a mask, a subnet mask. Again, this sounds mathematical and complex, but if you have a Class A address, the machine doesn't know that it's a Class A address. It doesn't know that it's a Class B address. It doesn't know that it's a Class C address. You have to use what's called a subnet mask. And the mask, we use the numbers 255 to set up the mask with. For a Class A address, we have 255.0.0.0. And that 255 will mask the net ID portion of the IP address. So if you have a Class A address and you're concerned with that first decimal number in the IP version 4 address, you will use 255.0.0.0. And that 255 will mask that first decimal number so that the computer knows that's the net ID portion of the address. The other 3 decimal numbers are host ID portion. They identify the host ID portion of the address. Now, if you have Class B, it's 255.255.0.0, because in a Class B address, the first two decimal numbers are important for the host ID portion to be separated from that net ID in the front there, those two numbers on the front. So you have 255.255.0.0. Then finally, in a Class C address, it's the first three decimal numbers that get masked by the 255. 255.255.255.0. Then that very last decimal number in the IPv4 address is the host ID portion of the address under Class C. Now it sounds complex, and I'm certainly willing and wanting you to send me any questions you may have about IPv4 addressing. And we can certainly have online chats to discuss how this works, in particular with addressing and what is known as subnetting. If you'll read the reading material very closely, you'll probably get a good idea of what I'm talking about, and then play this lecture several times. Otherwise, we can communicate through email and through your questions to help you to really understand how this works. I need to mention the point-to-point protocol. It provides a standard method for transmitting IP packets over serial point-to-point links, such as modems. PPP has a number of advantages over SLIP, serial link protocol. It is designed to operate over both asynchronous connection and bit-oriented synchronous systems. Since PPP is more advanced than SLIP, it can configure connections to a remote network dynamically and test to see if the link is okay. Now, when you, again, try to understand the IPv4 addressing system, try and remember that you're dealing with a dotted decimal notation, and there's 4 places. There's the first octet, the second octet, the third octet, and the fourth octet. And that address is made up of 4 parts. And again, a Class A address will go from 0 to 127. Then from there you have 128 to 191 for Class B. And then from there you have 192 to the upper level available address as high as 254. You can't have all zeros and all ones. And in fact, the all ones is really like a broadcast address. But the loopback address is a very special address, and I need to go back and mention that to you. The loopback address is the last address of each class, is actually used as a loopback address for testing. The loopback address is used on a computer to communicate with another process on the same computer. The most common loopback address that you'll ever see is the Class A one, 127.0.0.1. There's also a Class B one, 191.255.0.0, and there is a Class C address, 223.255.255.0. But don't be concerned with the Class A and Class C one. You won't see that one too often, but you will see the 127.0.0.1 address in use quite often. The broadcast address, which I mentioned, is if the host portion is set to all ones in a broadcast address, the packet with the broadcast address is sent to every node in the network. And when you look at that, this can be a bit of a congestion item on a network. For example, the address 129.49.255.255 The last two octets have 255 and 255 in them, and you're going to have all ones there in that host ID portion. And so it will become a broadcast address. And it can cause a lot of congestion on the network. So again, Internet is responsible for assigning your IP addresses, and a network administrator has to contact Internet and obtain an IP address, say for a university or for a business. The Internet will assign a Class B address with a network ID, for example, of 129.47 for the first 2 bytes of the IP address. The network administrator requires the 2 bytes. From these 2 bytes, he or she must decide how many bits are needed for each subnetwork. The answer is determined by how the network is growing and the future needs of, say, the business, the university, or whatever it might be for. So as you can see, there's a lot to addressing, and I've just given you some kind of basic introduction to it so you can begin to get your arms around it and try and understand it. Again, you're not called on to be a mathematician in this course, but to have a basic understanding of networking and, of course, IP addressing. Thanks for your attention, and I'll talk to you again soon.